Welcome to this video. So now we are going to see about geometrical modeling. So geometrical modeling means it is one of the mathematical description. It is used to generate a geometrical model. Okay, so normally we are using three methods in geometrical modeling. First one is wireframe modeling, and second one is surface modeling. Third one is solid modeling. So in wireframe modeling, this is one of the most popular and commonly used method of geometrical modeling. In construction of wireframe models and edges of an objects are present in the wireframe modeling. So in wireframe modeling, we are using two type of representation. One is 2D transformation or 2D representation, and second one is orthographical view representation. The basic difference between the 2D wireframe and 3D wireframe model is first thing is coordinate system. In 2D wireframe model, we are using only two coordinates, either x or y or yz or zx. Like only two coordinate system only we are using. In 3D wireframe model, we are using three coordinates, one x, y, z. In dimensional wireframe model, is generation is very difficult in 2D model, but in 3D model you can easily create 2D and 3D wireframe models. It is very possible, and also the hidden lines may not be complicated in the figure, but in 3D wireframe model, the viewer to interrupt the figures unless the hidden lines are removed. Okay, so now we are using Bezier curve to generate the sharp edges. So why is called as Bezier means Bezier the person to develop the curves to develop the sharp edges instead of curved shape. So that is called we called as Bezier curve. So normally it is used in automobile bodies. It's a Bezier curve normally. The four sharp edges are like point P0, P1, P2, P3, but we develop the design in curved shape. So for the aerodynamics force it will be reduced. So that where most of the automobile vehicles they are using Bezier curve like these shapes. So the main characteristic of Bezier curve is the Bezier can be defined of n plus 1 points. You can generate up to a number of points. The curve generally follows the shape of characteristic polygon. The degree of polynomial defining the curve segment is very least methods. Okay, and also the Bezier curve is more flexible comparatively the B-spline curve. So the difference between the B-spline curve and Bezier curve we are using only one curve, but in B-spline curve we are using multiple curves. So the characteristics of B-spline curve is the local control of curve can be obtained by changing the position of control point or using multiple control points by placing the several points at same location. A non-periodic B-spline curve passes through the first and last control points. It is a tangent to the first and last segment of the control polygon. So it allows to vary the number of control points used to design the curve without changing the degrees of polynomial. The degrees of curve increase, it is more difficult to control and calculate accurately. These cubes B-spline curves are more sufficient for application. This is B-spline curve. You can easily generate the more than two or a number of curves. So next one is rational curve. So in rational curve, it is a technique. It is one of the algebraic technique of two polynomial. They are non-rotational curve. We are using rational curves. Okay. Normally we are using Bezier curves for many applications. Okay. So next thing is surface modeling. And surface modeling is one of the technique used to represent the object and by the components of surface is called the surface modeling. The main objective of surface modeling is clearly interpret the users. And then the main drawback is here no data is available about the interior of solids. This is a very biggest disadvantages. And the application of surface modeling is in to develop the car bodies design, ship body design, aerospace structural designs like that. So the techniques available in the surface modeling is we are using surface path and cones path and bicubic patch. In bicubic patch we are using Hermite surface, Bezier surface and B-spline surface. Is a surface patch. In surface patch is defined in terms of point data will used to generate a rectangular array of data points. In computer graphics, the parametric surfaces are sometimes called as patches and curved surfaces or just surfaces. In building blocks of surfaces are known as surface patches. Okay, this is a surface patch. Normally we are using CAD. With the help of CAD we are draw the outer layer, but in surface patch we draw some inner layers. So with the help of surface patch we can easily identify the stress strain, the parameters. So next one is conic path. Conic path, the shape of the patch is irregular. That is called. It, see in this diagram, this surface patch is linear space. This is a non-linear space. So next one is bicubic surface. So bicubic patch or surface is used to generate the four boundary curves which are in parametric bicubic polynomial. So normally the parametric patches are defined over the rectangular domain. In UV space, the boundary curves of the patches are themselves cubic polynomial curves. The following are major three types of parametric bicubic surfaces. One is Hermitian curve, second one is Bezier curve, third one is B-spline curve. Okay, so this is a Bezier surface. So this is a Bezier surface. In Bezier surface, it is one kind of extension of Bezier curve in two parametric direction like U and V. Here in diagram, this is a U, this is V. So in orderly, the set of data or control points used to build a topological rectangular surface that is shown in here. So this is both U V direction you can create the models that is called Bezier surface. So next one is B-spline surface. In B-spline surface, it is an extension of B-spline curve. A rectangular set of data points is to be created in the surface. The B-spline surface can approximately used for the polyhedron. It will be shown in the figure. This is a polyhedron diagram. So you can create both regular as well as irregular shapes. So next thing is solid modeling. So solid modeling means it is one of the most effective geometric modeling method. So here in solid modeling approach, the models are to be displayed in a solid manner. The viewers can view the object in solid models. So thereby it will be eliminate the any chances of misinterpretation. Okay. Next, the solid model is used to make the object is more than very realistic. So normally we are using the following techniques in the solid modeling. The first one is half space method, second one is boundary representation method, and third one is CSG, that is constructive solid geometry method, and the fourth one is ASM, that is analytical solid geometry method, and primitive intentioning, sweep representation, and spatial parsing representation. These are the techniques we are using in solid modeling. So in most of the application we are using CSG, that is constructive solid geometry we are using. So this is one of the method we are using to create the solid models. So here the solid primitive includes cubes, spheres, cylinders, rectangle blocks are primitives to be developed. This is one of the type of CSG. So you can easily generate a square, cylinder, circle, rectangle, pyramid, etc. What all shapes you require, you can easily generate. So next one is CSG, that is constructive solid geometry model. Here the constructive solid model used to build the block approach. The physical object can be divided into the set of elements and combined in order of to form an object. So the advantage of CSG is this is requires the very less space. This method is advantageous in the initial creation of solid models using Boolean operation. It is easy to construct the solid models in perspectively. It will require only very skilled operators more than enough. So and also it is a more user friendly. The disadvantage of CSG is this method involves a more computational work for creating solid models, and also it complicated for solid geometry. This is not an appreciated method. and trees which are not unique shape. Okay, this is a boundary representation model. You see that edges, vertex, and face, loop, and body shapes. So the main advantage of boundary representation is this method is very powerful for creating the complex shapes in solid models, and then the boundary models can easily converted into wireframe models of system. The boundary system stores and explain the definition of the model's boundaries. The boundary system is very much compatible with the comparative to the other systems. So at reason the boundary representation is that it requires more storage space, and then this concept cannot be applied for the toolpath generation. So next we are going to see about CAD standard. So what standard we are going to discuss about means we are going to see the computer graphics standard and kernel system, that is graphics kernel system GKS, and then standard for exchange image, and then open graphics library, that is called OpenGL, and then data extensions like IGS, STIPS, CALs, and communication standards. Why we are using CAD standard? What is the purpose means? The main purpose of CAD standard is transfer of data between the dissimilar CAD CAM systems must embrace the complete description of product is stored in the database. So normally we are using four types of modeling data mix for CAD standards, that is shaped data, non-shaped data, as well as design data, and then manufacturing data. In shaped data means it will be consist of geometrical and topological data. So and then non-shaped data means it will be included the shaded image and measured units of database. And third one is design data. So that is FEA and financial analysis, and as well as ANSYS and engineering analysis. So it's a type of translator. So direct translator means system to system you can communicate the message with directly. So it is entire translating the modeling data directly from one native format to another. It requires the knowledge of both native formats. Like direct translator convert the data directly to one step. Like system 1 to system 5 you can communicate directly. So without any in between interpretations you can directly communicate. That is called direct translator. So next one is indirect translator. So it will be converts the modeling data directly from one native format to neutral format. So the neutral format that all CAD/CAM system can interpret the easily understand. Each translation system has its own pair of translator to translate the data into neutral format. Here, on neutral file is it will be the intermediate to give the data to the other system. This is the organization of typical layout of graphic standards. So in graphic system means either we are using what graphic system you require you can use. So in that system you have to give the input. So you give the input through the input channel, then the input is converted into digital form. So an application program to read the input signals. So based on the input signal the design standards will be generated. Next one is database management. So database management is one of the very essential methods to collect the data and will be stored in a different location. So if you store the data in a different location means when it will be required means you can easily recreate the models. So the main objective of database management is to provide a very secure manner. That's why we have to record the data, and also you have to use the elimination of unwanted data. This is the simplest database management architecture. So first application program users that you can develop the new programs means so your programs will be stored in the database management. So it will be in the one part of database. So the program is there in database means if you are in some other location means you will get the data from the database. For example, in COVID situation, most of the companies are running work from home condition. So here so all the companies access the data from database systems. So next for computer graphics standards. So why we are using computer graphics standard means it is one of the modeling methods will be used to effective utilization of standards. So the following standard means the outcome of computer graphics is very high. Okay. So normally you are using three CAD standard. One is graphical or computing standards and data exchange standards and communication standards. In graphical exchange standard, it is to translate that standard from one standard to another standard, that is one system to another system. So in data exchange system is it will be data exchange from one location to another location. So communication standard means you can only interact with the like message ways. You can communicate the through oral message or voice message, but you cannot exchange the data. Okay. So thanks for watching my video. So all of you request to subscribe my channel and press the bell button. Thank you.